Imagine the entire universe squeezed into a space smaller than an atom. This is where our story begins, with the Big Bang. About 13.8 billion years ago, this tiny point was incredibly hot and dense. Then suddenly, it expanded. This wasn't an explosion in space, but rather an expansion of space itself. The Big Bang is the leading explanation for how our universe began. It wasn't just an explosion of matter, but the expansion of space itself. This expansion continues to this day, meaning the universe is still growing. In the first fraction of a second after the Big Bang, the universe was an incredibly hot and dense soup of energy and particles. As it expanded, it cooled, and energy began to convert into matter. This marked the birth of the first fundamental particles like quarks, electrons, and their antiparticles. As the universe cooled further, these fundamental particles combined to form protons and neutrons, the building blocks of atoms. However, the universe was still too hot for atoms to form. Instead, protons and neutrons bounced around in a sea of radiation. About 380,000 years after the Big Bang, the universe had cooled enough for electrons to be captured by protons, forming the first atoms, primarily hydrogen and helium. This event is known as recombination. With electrons no longer scattering light, the universe became transparent. This era left behind a faint afterglow of the Big Bang, a cosmic microwave background radiation that we can still detect today. This radiation provides a glimpse into the early universe, like a baby picture of the cosmos. Gravity played a crucial role in shaping the universe. Over millions of years, gravity pulled together clumps of hydrogen and helium gas in the early universe. These clumps grew denser and hotter, eventually reaching temperatures and pressures high enough to ignite nuclear fusion. This process, where hydrogen atoms fused to form helium, released enormous amounts of energy, marking the birth of the first stars. These early stars were massive and short-lived, ending their lives in spectacular supernova explosions. Section 5. Galaxies, islands of stars. As stars were born and died, they created heavier elements like carbon, oxygen, and iron, scattering them into space. These elements then became the building blocks for new generations of stars, enriching the universe with the ingredients for planets and even life. Under the influence of gravity, stars clustered together to form vast collections called galaxies. Our own Milky Way galaxy, a barred spiral galaxy, began to form around this time. Section 6. Our cosmic cradle, the solar system. About 4.6 billion years ago, in a relatively quiet arm of the Milky Way, a cloud of gas and dust, perhaps the remnants of a supernova, began to collapse under its own gravity. This event marked the birth of our solar system. As the cloud collapsed, it began to spin faster, forming a rotating disk of material around a central growing protostar, our Sun. Within the disk, dust and ice particles collided and stuck together, gradually growing larger. Section 7. Earth. A blue planet emerges. These growing clumps within the protoplanetary disk eventually formed planets, including our own Earth. Initially a molten ball of rock, Earth cooled over millions of years, developing a solid crust and an atmosphere. Volcanic activity released gases from Earth's interior, contributing to the formation of the early atmosphere. Water vapor in the atmosphere condensed to form oceans, setting the stage for life to emerge. Section 8. The universe today and tomorrow. The universe continues to evolve. Galaxies move and interact, sometimes colliding and merging. Stars are born, live out their lives and die. And on at least one planet, life has evolved, capable of contemplating its own cosmic origins. The fate of the universe is still uncertain. It could continue to expand forever, growing colder and darker. Or gravity could eventually halt the expansion, leading to a big crunch, a reverse of the Big Bang. Section 9. Conclusion. An ever-evolving cosmos. From a tiny point of unimaginable density to a vast and intricate tapestry of stars, galaxies, and planets, the universe's journey has been nothing short of epic. As we continue to explore the cosmos, we uncover more about its history and our place within it. The universe is a dynamic and ever-changing place. Its evolution is a testament to the power of fundamental forces and the endless dance of matter and energy. As we delve deeper into the mysteries of the cosmos, we gain a profound appreciation for the grandeur and beauty of the universe we call home.